putting all of what we've learned together to solve equations, okay? We're going to practice solving some exponential equations here on the front side, and then I believe log equations are on the back side. So log equations, I'm sure, will definitely be tomorrow. We'll do what we can with exponential equations today. So in this first section, the heading gives us a clue. And you obviously won't be given that clue when you're working them, but solving exponential equations with a common base. Okay, so exponential because, of course, the x we want to solve for is in the exponent. As you look at A, 25 to the 3x equals 125 to the x plus 2. It says common base. I am looking for a common base. And this is the section your gold papers come in handy. Okay? If you can't spot it without it, you know. 25 and 125. How can I rewrite those with a common base? In other words, using a power. Okay? If you look at your gold paper, can you find 25 and 125 in the same grouping here? Yeah, 25 and 125 are both powers of 5. Okay, so this is where your gold paper can come in handy, because we can rewrite this. So 25 I can rewrite as 5 to the second, still raised to the 3x. 125 I can rewrite as 5 to the third, and then raised to the x plus 2. Okay? Now, exponent rules. What do we do when we're raising a power to a power? We multiply those powers. So as we look at 5 to the second raised to the 3x, that means we're going to take the 2 and the 3x and we're going to multiply. So that's going to give us 5 to the 6x. On the right, it's 5 to the third, and then raise to the x plus 2. So that means we're going to take the 3 and the x plus 2, and we're going to multiply them. When we take 3 and x plus 2 and multiply them, what do I get? Distribute that 3, and it's 3x plus 6. Okay. Back early on, we talked about the technique here. When x is in the exponent we're trying to solve, the bases are the same. Do you remember what we can do? Okay. If the bases are the same, we can drop the bases off and set the exponents equal to each other. Okay, and so the whole point of changing these to 5s is we got equal bases. So now I can drop the bases off, and I have the equation 6x equals 3x plus 6. Can we solve? How do you want to solve? Okay, if we try and get our x's on the same side, subtract 3x since it's a positive 3x. 6x minus 3x is 3x. On the right, 3x minus 3x cancels, leaving me with 6. If it's 3x equals 6, we're going to divide by 3. And x is 2. Could I check my solution? Mm-hmm. You can. Okay, you could use a calculator. You can check. Okay, if I do 2 up here, 3 times 2 is 6. 2 times 6 is 12. This is going to be 5 to the 12th. Over here, 2 plus 2 is 4 times the 3. That's 12. It's going to be 5 to the 12th. I'm going to have the same both sides. Okay. Questions? Okay, let's try a couple more. Okay, that was your initial easy entry level, right? The 25, 125, that's on the easier side. We can see them both in the same column here. Now we've got to think about B. 1/2 to the x plus 7 equals 4 to the 3x. We're looking for common bases here again. You see 2's? What do we know about 4? Can 4 be a power of 2? It's 2 squared, yes? What about this 2 in the denominator? Remember, to get a number out of a denominator, you move it up. Okay, so right now, this is 1 over 2 to the first, if you will, right? So when you see those fractions, we can think about it. And so we're going to take this and make it 2 to the negative first, raised to the x plus 7. Okay. On the right, the more obvious piece is that we know 4 is 2 to what power? Two to the second, and then raised to the 3x. Okay. Am I on the right path? Did I get my bases the same? Yeah. Okay. So here, for the moment, keep the base of 2. How do we do this power raised to a power? We're going to multiply, right? So what is negative 1 times x plus 7? That is
Negative 1x minus 7.
okay. Negative x minus 7. On the right, 2 to the second raised to the 3x is 2 to what power? 2 to the 6x. Okay. And from there, drop off the bases of 2 because they're the same. Negative x minus 7 equals 6x. And we're going to if we already have the 6x by itself over here, I agree that moving the negative x and adding x over, your brain can handle the x's being on the right. It's a good thing here. So negative x plus x cancels. I have negative 7 equals 6x plus x is 7x. And if 7x equals negative 7, we're going to divide by 7, and x is negative 1. Okay, so there's your example when they throw a fraction in at you. Think about that denominator, what power it can be, and then raise it up, okay? C. There you go.
Pardon the interruption. If you're an anatomy student and you're going with Mr. Kevin today, please report to the middle school bus entrance. You're ready to go.
Okay, C. Thoughts on what to do here when we throw a decimal at you instead of a fraction. So we have 1/1000 equals 10 to the 6x. And my thought would be, what about this decimal? Okay, can that be rewritten as a fraction? Yeah. This is tenths, hundredths, thousandths, right? So as I properly read it, 1/1000th equals 10 to the 6x. Now maybe you can see it a little bit better. Now, I'll be honest, this is where the gold paper doesn't technically help you. But I'm hoping you know what to do with it. Okay? What can these both be powers of? Tens, yes? Okay. 1,000. That is 10 to what power? There's 3 zeros, so it's 10 to the power of 3. So if 1/1000 is 1 over 10 to the third, and I'm taking an extra step. You may have jumped steps already. What do we know about 10 to the third that's in the denominator? To get it out of the denominator, it's going to be 10 to the negative 3. Once you hit this point of both bases are 10s, then we're good to go. Okay? So anytime you start talking 10, 100, 1,000, a million, think powers of 10s and count your zeros. Okay, so my bases are the same. Drop your bases. We have the equation negative 3 equals 6x. And what are you doing? Dividing by 6. What are we getting? Okay. Negative 3 divided by 6, negative 3/6, which reduces to negative 1/2. Okay. I'll be honest, I like those. I like getting the bases the same. Some of you may not like this because you may not, as easily see that the bases are the same. So this is one type of problem you'll see, okay? And the first step I'm always going to ask you or recommend is, can we make these bases the same? Okay? Now, as we move down to the next set, solve each equation, and they give us a hint here. Well, it says solving exponential equations with different bases. And it says solve each equation using logarithms. Round to the nearest 10,000th as needed. Okay? As we look at 3 to the x equals 15. Can I get 3 and 15 to be some number to the same number to a power? No. 3, the only option for 3 is 3 to the first. 15 is 3 times 15. It's not a power of anything. So this is the other type of exponential equation we run into where the gold paper doesn't help because 3 and 15 don't fall into the same column anywhere. So we need plan B. And plan B, solve using logs. We're going to take the logarithm of each side. Okay? So when I say take the logarithm of each side, all I mean is we're going to write the word log in front of each side. So 3 to the x is going to become the log of 3 to the x. 15 is going to become the log of 15. Okay. Use prior knowledge. What have I already taught this week? What can I do with that x? What? That was a sarcastic answer, wasn't it? Can't do left, right, middle when I have 2 logs. So not a sarcastic answer, but no, can't use it. Think about our properties. We had 3 properties in the last lesson. Where can I move that x? Power property says that we can take an x out of the exponent here and move it where? To the front. So we're going to do just that. So now I'm going to have x times log of 3 equals log of 15. Guys, we're almost there. How do I solve for x? Okay. So if this is x times log of 3, yes? I want to get x by itself. It's x being multiplied by log of 3 is just some number. Some number that my calculator knows that I don't. Okay? So if that's x times log of 3, to get x by itself, and we can do this because x isn't in the log, it's out front, we're going to divide by log of 3. What you do to one side, you do to the other side. Are you guys seeing that orange okay? I just realized I'm using a lot of orange. Is that visible or no? Okay. I'm seeing some yeses and some debatables. I probably need to quit using the orange then. I'm assuming the blue's good, right? That orange is probably debatable for some. Okay. I like the orange though, but.
I can see it.
Okay. The idea here, log of 3 cancels with log of 3. We're going to have x is equal to whatever log of 15 divided by log of 3 is. Folks, I told you you have a calculator at your desk, didn't I? Here's your need.
2.465.
Okay, 2.465, because the next digit is,
So 9 to round
okay,
up. It wasn't 4.
okay. Which, by the way, round to nearest 10,000, tenths, hundredths, thousandths, 10,000ths. So that is 4 places. And it does round to be 2.465. I have 0 written on my notes. Do you have to write that 0? You do not. Okay. Okay. I'm not the chemistry teacher. I'm the math person, so.
That's not proper digits.
Huh?
Dog would not be proud.
Well, we don't talk sig figs in math, so. Okay. And you guys got the answer on the calculator, okay? Your calculator stuff, piece of cake at this point. Okay, so 2.4649. The 7 tells the 9 to go up, which is essentially telling the 49 to go up, right? Okay. There's your basic, folks. That's our basic example. We've got to change it up a little bit and get a little more fancy, right? Okay. This had one nice x and one exponent. Not going to be the typical problem, though. Okay. If there's no questions, let's try B. I have 4 plus 5 to the 6 minus x equals 15. Now, this one has a little bit different start. Because before I can ask, can you make the bases the same, what probably needs to happen? We can't really talk about whether I can make the bases the same because it's not set up like this one, where it's 3 to the x equals 15, where it's something to a power and then just some number on the other side. What needs to move here before we can talk about making the bases the same or taking the log of both sides? Yeah, that 4 needs to move. You need to get that power by itself before you do anything. So we need to get the 5 to the 6 minus x by itself. In order to get the 5 to the 6 minus x by itself, we're going to subtract the 4 over. It's a positive 4, so I'm subtracting 4. So now, 5 to the 6 minus x is equal to, what's 15 minus 4? 11. Now, if I'm in Savas and it's not telling me how to solve, my question is going to be, can I make 5 and 11 be the same base? No, because 11 is not a power of anything. Neither is, they're just 5 times 1, 11 times 1. So, since I can't make the bases the same, what we just learned, we're going to take the log of both sides. So basically, just write log in front of each side. Log of 5 to the 6 minus x is equal to log of 11. What did we do last time? Okay, we're going to move that power out front. Now, the difference this time is my power is not just a single term. It's 2 pieces. So I'm going to move this 6 minus x out front. I'm going to put it in parentheses because it's the whole quantity, 6 minus x being multiplied by log 5. So I have mine written as the quantity 6 minus x times log 5 equals log 11. I hope that you guys are fitting this better because I'm going to run out of room real quick, I'm realizing. I should have blown my paper up and put the other examples on another page, but too late. Any thoughts of how to solve for x? Okay. So We need to work to get that x by itself, yes? And there's technically two different ways. What Patrick has said is what I would probably recommend for you guys anyways, is that first of all, let's start by getting the log 5 away. So that would be dividing by log 5. If we divide one side by log 5, we're going to divide the other side by log 5. Now on the left, what's that mean we have? That means we have just 6 minus x, yes? On the right, log 11 by log 5 is a decimal. It's a calculator answer, yes? Me personally, I can go ahead and put in my calculator, but I'm not going to write that decimal down because I don't want to use a rounded version of that decimal. I want to use that whole value in my calculator. So for right now, I'm going to leave it as log 11 divided by log 5 in my paper. If you want to write that decimal down, whatever it might be instead, that's fine. Just you don't want to use the rounded version when you actually do the calculation, okay? My thought is I'll put everything in the calculator at the end. So what do I need to do now to solve for x? Okay, so we're going to work to get that 6 over because we're gradually, bit by bit, I'm trying to isolate my x. So subtract 6, which subtract 6, here's what I'm going to do. Minus 6. Okay? So at this point, it's when I run out of room, but I have negative x equals log of 11 divided by log of 5 minus 6. Okay? And somehow or another, you need to get rid of that negative, yes? Okay? Logan says flip the sign. We can multiply everything, that's multiplying everything by negative 1, or it's dividing everything by negative 1. Okay? I think easiest for me would be to say, okay, if I multiply everything by negative 1, then that means I'm multiplying this whole side by negative 1. And again, there's different ways you can do this. I'm going to bring mine up here. So if I multiply everything by negative 1, this fraction, log 11 over log 5, becomes negative of log 11 over log 5. Minus 6 would become plus 6. That's just one way to do it. Okay, there's several ways we could write that final answer, but it's not really a final answer because we're still going to put it in the calculator. Okay, so this is where, as I keep mentioning, try your calculators, yes? You could enter it slightly different than mine and get the same answer. You should have 4 point something when you get done, I believe.
4.5101.
Something like, I just remember seeing 4.5 in my paper before I walked away, so. Now, so if I do this, you can also do this in just pieces, right? So if I say negative, use a negative, not a minus, log of 11 in my parentheses divided by log of 5 in your parentheses, and then it became plus 6. There's one way to get the answer. Okay? And again, there's other right ways to enter this on the calculator, so by all means, I'm always willing to help there. We are going for 4 decimal places, so that was that 4.5101. Okay, guys. This is where they get a little bit difficult, okay? It's nice and easy when you just take the log and everything works out easily. We have to do some maneuvering on a lot of these. And that's where it's going to take some practice. Okay, you ready to try C? C, 3 to the x plus 1 equals 5 to the x. I'm still going to keep asking just to be in the habit. Can 3 and 5 be written as the same base? No, 3 and 5 don't have anything in common. So if I can't write them as the same base, we're going to take the log of both sides. Log of 3 to the x plus 1 equals log of 5 to the x. And then we're going to use our power property and move the powers out front. And this means this time you're moving both powers out front. So here I'm going to have x plus 1 times log of 3. Notice x plus 1, since it's two pieces, I put in parentheses. And over here, it's going to be x times log of 5, or x log of 5. Okay. Thoughts of where you want to go? Are you talking about this x? We cannot, because it's part of the x plus 1 that's being multiplied by log 3. Okay. I have divide by log 3 up here. I'm going to say technically we could. Would I want to? I'm just trying to think how I'd end up getting my x's together then. And I'm not sure I want to go that route. I need to play with it and see how it works out. But here's what I'm going to tell you. I think it doesn't work out very great. Okay. Log 3. Log 3 is a number, yes? Some calculator number. Okay, it's a number. When you have a number outside of a parentheses, what is an option? Yes, we could divide it off, and I would like this one, except that I have x's on both sides, and that's why I'm hesitating. What's the other option besides dividing that log 3 away? Distribute. Okay. So what I'm going to suggest we do is take the log 3, it's a number, and we're going to distribute it into the parentheses. So first of all, we're going to say log 3 times x, which I'm going to write that as x log 3, just because if you put the x at the end, is it or isn't it in the log, plus, what's 1 times log 3? 1 times anything is just that thing, so log 3 still equals x log 5. Okay. By distributing, what I've done is I have 3 terms now. 2 of those terms have x's, 1 does not. So you want to get the x's together. How could I get the x's together on the same side? Subtract which one? Okay. Since I already have x log 5, on the right, that x term is by itself. Let's take the x log 3 and send it over to join the party on the right. So we're going to subtract, where do I want to put it? X log 3. What I do on one side, we of course are going to do on the other side. On the left, of course, x log 3 minus x log 3, gone. I'm left with log 3. On the right, x log 5 minus x log 3 is just that. X log 5 minus x log 3. We cannot add and subtract logs. If you want to add and subtract logs, we'd have to start talking about like terms. Log 5 and log 3, They're not blank. Okay. The one other trick. We set it up so both terms on the right side both have an x, yes? Okay. If both of these terms have an x, x is what I would call the, do I dare throw the word GCF out there? Okay. X is what is a common piece here. Okay. And so what I'm going to suggest we do is factor that x out, and then I think you'll see the step to finish us off. We're almost there. Both terms have an x. That's what we wanted. So factor the x out, which means I'm going to put x out front. If it's x log 5 and I factor that x out, what remains? Log 5 minus, if it's x log 3, you factor that x out, you're left with log 3. Okay. Do you see where we're going to go next? What's x doing? It's x times that big old quantity, yes? How do you solve when it's x times something? We're going to divide, yes? So we're going to divide by log 5 minus log 3. Which means over here on the other side where we have log 3, we're dividing by log 5 minus log 3. Okay. I am really out of room there. You're putting in your calculator what we have on that left there. Okay? You're going to put in your calculator log 3 divided by log 5 minus log 3. Okay? You will notice I left parentheses around that denominator. There is a right way and a wrong way to put this in the calculator. Anytime you put more than one thing in a denominator, you need to use parentheses around your denominator. Okay? So when I do this on the denominator, log 3 on top. I ended my parentheses. Now it's going to be dividing by. If you have more than one piece in that denominator, you must start a set of parentheses. So parentheses, and then what's going in there? Log 5 minus log 3. So log 5 in the parentheses on the 5 minus log 3 in the parentheses on the 3 and technically in the parentheses on the denominator. Does your answer match my answer? If so, you did something correctly on the calculator. If not, you did something incorrectly on the calculator. What is this going to become? $2.1507. I'm bringing mine off to the side. I'm too low there. I can't write it there. Okay, guys. Those take a little work, I know. Okay. We'll start tomorrow talking about D and how to go about with that. D is going to be kind of similar to what we just did. So we'll use that example to look back on. And then we'll talk about how to solve log equations on the back. Okay.